Record kita. Okay. So this week we are going to cover module 2.4, which is the genetic algorithm. It's an advanced search. Okay. So let's proceed. Okay. If you see the name already, you can kind of guess what we are going to learn today. We're not going to learn biology, obviously, but we're just going to learn how this um, uh, genetic algorithm that we can use in order to solve some problems given to you. Okay, so we want to find the most optimum value, the most optimum x value. Let's say we have number 0 to number 100, and then we have this function. How can we get the most optimum x value given this using this function? Okay, that's what we are going to learn today. But before that, we are going to go through all the theoretical part lah. Okay, the theoretical part of the genetic algorithm itself. Before we go through to the calculation and the example. Okay, so basically we will take a look at the natural evaluations. Okay, how in our daily life how we evaluate uh, the natural, how we evolve in life. Okay, and then versus the artificial evaluations. And then after that, we are going to go through the genetic algorithm steps and the population selections and the reproductions using the genetic algorithms. And lastly, we will go through the calculation part. Okay, given the function, given the values, okay, how can you calculate? How can you calculate the score? Okay, we want to find the most fit score. Okay, so that is the last part of the lecture for today. All right, so how the natural evaluation work? Okay, you can basically read yourself, okay, about in this paragraph. So basically, it's based on the process of reproduction, mutation, competition, and selection. Okay, reproduction ni like us lah. We reproduce. Okay, we human reproduce to create more population to the world. Mutation. Okay, mutation. You can see several insects. They are mutated already when you use some um insect repellent cream, sometimes it wouldn't work. Like say we put insect repellent lotion before we go to camping, but you still got bitten by some mosquitoes or some other insects while you were camping because they might have mutated, they might have become immune to that specific insect repellent lotion already. Okay, that can be called as the mutations. When the species are, will try to evolve, will try to improve their immune system, their genetics chromosome to be better. Okay, and competition in life. Okay, as a human, we also compete. Okay, we compete like let's say back in the day, I'm not sure about right now, but back in the day, only whoever that got 5 A's or UPSR can go to the boarding school, can go to MRSM, right? Competitions. Okay, only the chosen one. Okay, and selection. Okay, selection. Okay, the school have to select only a group of students. Okay, based on the quota given by the government. Okay, That's how we see the natural evaluations in our daily life. Okay, so these evolutions can be seen as a process of leading to the maintenance of the population's ability to survive. Okay, like I said earlier, the insects repellents, okay, they improve in order for them to survive and reproduce in a specific environment. Okay, they reproduce and then they have a better new populations, okay, to match the environment. This ability we call as the evolutionary fitness. Okay, so the evolutionary fitness can also be viewed as a measure of the organism's ability to anticipate changes in its environment. Okay, anticipate changes. Okay, so the fitness or the quantitative measures of the ability to predict environmental changes and respond adequately. Okay, if you go to the countries that have so let's say you go to the North Pole. Okay, the North Pole. We have the white bear, right? The white bear. How their body was built to fit with the weather over there. How cold is the weather over there? It can be minus Celsius. Okay, how their body were built to adapt with the environment, that they will survive without even using any kind of coats like we human needs to. Okay, that's what we call as the ability, okay, to adapt with the environment. So let us consider a population of rabbit. Okay, some rabbits are faster than others, and we may say that these rabbits possess superior fitness because they have a greater chance of avoiding foxes, surviving than breeding. Okay, several rabbits are fast, several rabbits are slower. So the tendency of those rabbits that can move faster to survive is higher compared to the rabbits that are weaker and slower. And then these faster rabbits will be able to survive attacks from any foxes or any kind of attack from other animals, survive and breed and produce more uh, rabbits population that have superior fitness like the parents. So if the parents have a superior fitness, okay, there is a good chance that a combination of these genes will produce an offspring, maksudnya a child, with even higher fitness. Okay, maksudnya if the rabbit is fast and then with two fast rabbits mate and then they produce baby rabbits, this baby rabbit have the tendencies to be even faster than its parents. Okay, so over the time of the entire population of rabbits become faster to meet their environmental changes in the face of foxes. Okay, same goes to human also. Okay, same goes to human. Let's say both mom and dad are wearing glasses. Okay, there will be high tendencies that all the kids will be wearing glasses. Like my family, like both my mom and dad wear glasses. So like me and all my siblings wear glasses. Okay. So especially the mom will play the most genes, will contribute the most genes to the kids. Okay, if the mom have diabetics, so there are high tendencies for the kids to, to eventually get the diabetes also. Not 100%, but have the higher tendencies compared to the dad. If dad only have diabetic and mom doesn't have diabetic, there's only a 50-50 chance for the kids to get diabetic. Okay, all right. So all simulation of natural evaluation. So all methods of evolutionary computations simulate natural evolution by creating a populations of individuals, evaluating their fitness, generate a new population through the genetic operations and repeat the process for a number of times. Okay, so that's just the theoretical part lah for you to understand. So we will start with genetic algorithm. Okay, genetic algorithm. Most of the other evolutionary algorithm can be viewed as the variations of genetics algorithm. Okay, genetic algorithms. So genetic algorithms, it started in the early 1970s. Okay, by John Holland. So John Holland he introduced the concept of genetic algorithm. Okay, what happened was he wants to make computer do what nature does. Okay, he wants the computer to be smart enough to change based on the problem, to change to find the solution based on the given problem. Okay, so Holland was concerned with algorithms that manipulate strings of binary digits. Okay, strings of binary digits, they mean the 0, 1 sequence of strings. Okay, so each artificial chromosomes consists of a number of genes. Okay, and each gene can be represented by 0, 1, A, B, Z, whatever. Okay, it doesn't need to be only 0 or 1, but it can be represent as any kind of words or any kind of numbers. So nature has the ability to adapt and learn without being told what to do. Okay, because nature, okay, scientifically talking, that the animals, humans, and um, plants, everything have their own role, and then they adapt to the environment changes. Okay, in other words, natures will find good chromosome blindly. Okay, so that's what genetic algorithm wants to do. Okay, they will uh, solve the problem by encoding and evaluate the problem. So the genetic algorithm use a measure of fitness of individual chromosome. So we will calculate the fitness of the individual chromosome to carry out the reproduction. So as the reproduction takes place, the crossover operator exchange part of two single chromosomes, and the mutation operator change the gene value in some randomly chosen locations of the chromosomes. Okay, ni we will explain further. Macam mana kita buat crossover, macam mana kita buat mutation on the given chromosome. Chromosome in our case here is like, let's say, a sequence of binary strings. Okay. So now let's take a look at the steps of genetic algorithms. Okay, first we represent the problem variables domains as a chromosome of a fixed length. Okay, we choose the size of a chromosome population N and the crossover probability and the mutation probability. Okay, that's the first step. And then the second step, we define the fitness function. Okay, the fitness function to measure the performance or the fitness of an individual chromosome of the problem domain. The fitness function establishes the basis of the selecting chromosome that will be mated during the reproduction. Okay. And then step 3, we randomly generate an initial population of the chromosome size N. Okay, let's say your question says we have create uh, 5 binary bit chromosome of size 30. That means you will create like 30 binary sequence. Okay, this will be 1. Okay, to just randomly correct, randomly generate. Okay, all right. And step 4, we calculate the fitness of each individual chromosomes. Okay, given the function, okay, you will be given the function and then you will have the x value and then you just put the x value in your function and then calculate the fitness of each chromosome ni. So each chromosome ni it will have the integer number that represent the x value. Okay, you use the x value put in the function. Okay, and then you will have the fitness for each individual chromosome. Ni kita panggil satu ni chromosome. Ni chromosome satu, ni chromosome dua. Like that. So step 5, we select a pair of chromosomes formatting from the current population. Okay, kita pilih choose 2 chromosomes untuk kita buat the reproduction. Okay, and then step 6, we create a pair of offspring chromosome by applying the genetic operator, crossover, the mutation. After we select those 2 chromosome, we do the crossover and mutations. But make sure to select the chromosome that have probability related to their fitness. Maksudnya highly fit chromosome with higher probability of being selected. Okay. And then step 7, we place the created offspring chromosomes in the new population. So after we do the crossover and the mutations, okay, so there will be new offspring, okay, new chromosomes. Okay, we put that new chromosome into the new population. So now we will have 2 population, the original population and the created populations. And then we repeat step 5 until the size of new chromosome population becomes equal to the size of the initial population. Okay, repeat until the size of population is same. Step 9, we replace the initial chromosome, okay, the parent chromosome population with the new, which means the offspring populations. Okay, kita replace. And after that, step 10, we go to step 4 and then we repeat the process until termination criterion is satisfied. Okay. So this is the process. Okay. Initiate and evaluate. Okay. You initiate with the original population and you select. Okay. You select the parents, select 2 parents to do the modification. And then after modification, you evaluate. Then you evaluate the offspring and create a new population. And then keep repeating the process until you got to the termination criteria. Okay? All right. So, chromosome, okay, population ni population will consist of chromosomes. So chromosomes could be, okay, it could be bit strings like this. It could be real numbers. It could be permutations of element. It could be list of rows. It could be any genetic programming elements. Or it could be any data structures. Okay, it depends on the problem given to you. Okay, parent selection. Okay, parent selection. So parents are selected at random with selection chances bias in relation to chromosome evaluation. Okay, so we will have a population and then we select 2 chromosomes to be the parents in order to generate the children. And then the evaluator decodes a chromosome and assign it a fitness measure. Okay, assign the fitness measure. That means given the fitness function, we will calculate the fitness measure for each child, each new chromosomes. So what is actually fitness function? Okay, fitness function lah yang we will use to calculate the fitness value of each chromosome. Okay, so fitness function ni actually it determines which possible solution get passed on to multiply and mutate into the next generation of solutions. Okay, so normally the fitness function we do it by analyzing the genes. Okay, where it holds some data about a particular solution to the problem you are trying to solve. So the fitness function will look at the gene and make some qualitative assessment and return to you a fitness value for that solution. So the rest of the genetic algorithm will discard any solution with a poor fitness value. And then we will accept good fitness value. Okay. So the main idea that you can get regarding the fitness function is fitness function try to provide a meaningful, measurable, and comparable value given a set of genes. Okay, that's the goal of fitness function. Okay, remember this. All right. So parents or survivor selection. Okay, choosing the parents. Okay, the strategy in choosing the parents chromosome is always keep the best one and delete the worst. Okay, so the selection of the parents of the next generation of candidate solutions. Okay, it will affect the solution. The moment which chromosome that you select to be the parent, it will affect your solution. So the selection methods, there are two selection methods in order to select the parents. One is roulette wheel and one is tournament. So too strong fitness selection bias can lead to suboptimal solution. Okay. Too little fitness bias selection results in unfocused and meandering search. Sorry. Excuse me. All right. So this is how roulette wheel looks like. So how roulette wheel works, it will add up the fitness of all chromosomes. Okay, right now we have 6 chromosomes right here. And then this is the fitness value of each chromosome. Okay. So roulette wheel will generate a random number R in that range. Okay. First, it will select the first chromosome in the population that when all previous fitness are added, give you at least the value R. So for this one, we started at 16.5, which is the fitness value for X1. And then you added up X1 add with X2, so 16.5 plus 20.2, it will give you a new value of 36.2. Add up with X3, which is 6.4, will give you 43.1. Add up X4, 6.4, give you 49.5. Add up X5, 25.3, give you 75.2. And add up X6, 24.8, give you the total is 100. Okay, that's the roulette wheel. And the binary tournaments, okay, binary tournaments. Okay, so tournament, there are 3 kinds. Okay, first one is binary tournament. Binary tournament is when 2 individuals are randomly chosen. Okay, the feeder of the 2 is selected as the parent, maksudnya the most fittest one. And the second one is the probabilistic binary tournament. So for this one, 2 individuals are chosen at random and the better of the 2 individuals is selected with fixed probability of p between 0.5 and 1. And for the larger tournament, and individuals are randomly chosen. So the fittest one is selected as the parents. Okay. Now let's take a look at the reproduction operators. So reproduction operators, we have two here. We have crossover and we have mutation. Okay. So these two reproduction operator will do the modification to the chromosomes, to the parent chromosome, and create a new chromosome we call as the offspring or the child chromosomes. Okay, it will do the mutations and it will do the crossover. Okay, so what is actually these terms of crossover and mutations? Okay, so crossover, okay, two parents will produce two offspring. Okay, we have two strings, okay, strings A, strings B. These two will create a new two strings, okay, based on the strings of these parents. Okay, so there is a chance that the chromosome of the two parents are copied unmodified as offspring. Okay, there is tendencies that it's just going to be similar chromosomes. Okay, there is a chance that chromosome of the two parents are randomly recombined to form offspring. So generally a chance of crossover is between 0.6 and 1.0. Okay, that is crossover. And for mutation, there is a chance that a gene of child is changed randomly. Maksudnya, if we have several binary sequence here, we might change, like, let's say this part 0 to 1. Okay, then the new chromosome will be 0 1 1 0 1. Okay, that's the process of mutation. You select one gene or two gene, how many gene depends on you, to create a new offspring. Okay, that's uh, the process of mutations. Okay, so the crossover operators, so it will generate offspring from two selected parents. Okay, from the two selected parents. You can do single point crossover and you can also do 2-point crossover. Okay, so we will take a look at the example about all these terms. Okay, don't worry. So crossover is a genetic operator used to vary the programming of a chromosome from one generation to the next. Okay, it is analogous to reproduction and biological crossover upon which genetic algorithms are based. So crossover process will take more than one parent solution and produce child solution. Okay, kita ambil two parents and then we create child based on those two parents. So the crossover techniques, it can be 1-point, it can be 2-point, it can be uniform crossover. Okay. So let's take a look at the 1-point crossover. Okay. For 1-point crossover, what you have to do, you will randomly one position in the chromosome is chosen. Randomly one position is chosen. So the child 1 is the head of chromosome of parent 1 with a tail of chromosome of parent 2. And child 2 is a head for 2 with tail of 1. So we have these parents, okay? These parents, okay? Let's say parents A, parents B, okay? So we select to do the crossover, 1-point crossover right here, okay? So this will be the head and this will be the tail. So crossover process, when you exchange the tail part of these two parents. Okay, you exchange the tail part of these two parents. You don't change the head, you just change the tail. Okay, so this one will be 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, and this one will be 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, 0. So this is the new chromosome. This is we call as the child chromosome, the offspring from the parents. Okay, so far understand, huh? Okay, so that one is the 1 point crossover. This one is 2 point crossover. 2 point crossover, you randomly choose two position in the chromosomes. Okay, we avoid that genes at the head and genes at the tail of the chromosome. Okay, all right. So 2 points. So we select 2 points to do the crossover. Okay, so this one will be the head. This will be the tail. Okay, so what you have to do, you have to exchange the middle part here. The middle part, the sequence in the middle for 2 point crossover. Okay, so this is the parents, right? This is the parents. Okay, so you change from 0, 0, 0, 0. Okay, you change this part. Okay, dia jadi 0, 0, 0, 0, 1, 1, 1, 1, 1 and 0, 0, 0, 0. Okay, the second child will be 1, 1, 1, 1, 1, 0, 0, 0, 1, 1, 1, 1, 1. Okay, so that is for 2 point crossover. Okay, so to the second operator, which is the mutations. Okay, mutations operator. So for mutation is a genetic operator used to maintain the genetic diversity from one generation of a population. Okay, so it is analogous to the biological mutations. Mutation actually alter one or more gene values in a chromosome from the initial states. Okay, so let's take a look at the example. So we trying to mutate these parents. We mutate these parents since this is a binary strings. You can only change the value like either 0 or 1. Okay, so we change this these genes from these chromosomes. Okay, we change 1, make it 0. So this chromosome have been mutated and create a new offspring. The mutated offspring. Okay, it become 1, 1, 1, 0 and 1, 1, 1, 1, 1. Okay, that's the mutation process. You can also change different you can also change multiple genes as mentioned here, one or more genes. Okay, okay, now let's take a look at the example. Okay, we have a case study here. Okay, we have a case study. So the case study, let us find the maximum value of function. Okay, this is the function 15x minus x squared, where parameter x varies between 1 to 15. Okay, maksudnya the value x ni must be between 1 to 15. Okay, cannot be more than that. So for simplicity, we may assume that x only takes integer values. Okay, x only integer. Maksudnya number 1 to 15 integer only. Tak boleh point. Thus, table below shows the possible chromosome that built with only 4 genes. With only 4 genes. Maksudnya ada 4 genes je lah. Okay, 4 genes only. You see, 0001, 0010, 4 genes only. Okay. Alright. So ni table. Ni table. So we have integer here. Integer here is the x value. This is the chromosome. Okay. Chromosome. Okay. Integer value 1, this chromosome. Integer value 2, this chromosome. Okay. So now, suppose that the size of chromosomes population N is 6. Okay, maksudnya ada 6 chromosomes. Okay, the crossover probability equals to 0.7. Okay, the crossover probability. And the mutation probability equals to 0.001. And the fitness function is defined by these functions. Okay, so we begin with calculating these two. Okay, these two parts. So we have 6 chromosomes. Okay, 6 chromosomes chosen. Okay, and then the chromosome strings, and then they are decoded integer. And how can we calculate this chromosome fitness and the fitness ratio? So we have the formula given here, 15x minus x squared. So 15x minus x squared. So using this formula, you just put the x value, which is this value, in the formula to get this value. So let's say the first chromosome. The first chromosome x value is 12. So we have 15, 12 minus 12 square. Try to calculate. Did you get 36? Cuba calculate. Did you get 36? Dapat tak?
Dapat Mel.
Dapat ada.
Yes.
Okay. That one for the first chromosome. And then the second chromosome, same. Okay, you just put the x value into the formula. Okay, 15, 4 minus 4 square. Okay, so calculate the chromosome fitness. Okay, now you get all these values. After that, how can we get the fitness ratio? Okay, you add up all this value. You add up all the total chromosome fitness. 36 plus 44 plus 14 plus 14 plus 56 plus 54. What is the total? Anybody can tell me?
218.
218. Thank you. So 218 is the total chromosome fitness for all these 6 chromosomes. Now kita dah ada total, we have to calculate the fitness ratio. Okay, the fitness ratio is you take this chromosome fitness bahagi dengan total times 100 because dia nak dalam bentuk percentage, right? So bahagi dengan darab 100. So untuk X1, so you have 36 over 218 times 100. Then you will get this 16.5. Wait, Josh. Okay. Sama juga this one. X2. X2 44 over 218 times 100. Dapatlah 20.2. Okay. So from there you got the chromosome fitness and the fitness ratio. Okay. So kita sekarang nak cari the most optimum X value, right? The most optimum X value. Okay, so if we map our x value with the fx, okay, with the function here, okay, we have 12, we have 4, 1, 14. Okay, we map here to get to the functions. You can see the most optimum value from the graph. Okay, the highest at the peak is the optimum value. You can see the most optimum value here is when the value of x is 7. Okay, 7. And the chromosome fitness is 50, 56 here. Okay, so for the Roulet wheel, this one that we went through earlier lah. Okay, the Roulet wheel selection techniques. Okay, we start with the first chromosome. We added up. Okay, we added up until chromosome 6 and we got 100. Okay, so now we already have all the values for the parents. But now we have to, let's say we do the crossover. Okay, we do the crossover. So let's say we want to cross between x6 and x2. Okay, so x6 we have 10001001, and then x2 we have 0100. So we want to do the 1 point crossover. So we exchange the tail. Okay, so the new x6 will be 1000, and the new x2 will be 0101. Okay, that for x6 and x2. And then how about you change the x1 and x5? Okay, you change x1 and x5. Okay, 1 point crossover. Okay, so the new x1 will be 1111, and the new x5, the new chromosome, that means we are creating the offspring right now, right? Okay, x5 is, the new x5 is 0100. Okay, all right. X2. Okay. So after that, we do the mutations. We do the mutations. Okay, we have the new x6, the new x2, okay, the new x5. Okay, now what is that sound? What is that sound? Battery low. Okay, if you guys suddenly cannot hear me, let me know. Okay. All right. So we're almost done here. So we do the mutation. Mutation. Okay. We do the mutation when we switch the gene for X1 and the gene for X2. Okay. All right. So after those process, okay, this is generation, the original generation lah. Okay, the original generation. This is the fitness value that we calculate earlier in the table. Okay. And then you do the crossover and mutations and you got the new generation. New generation. Okay, the new generation, the offspring from this one. And then once you do once you have the new generation, and then you will have a new fitness value. Okay. So after the calculation, if you repeat the calculation again, okay, so we will get number 7 and number 8 are the optimum number for this for this fitness function. Okay, number 7 and 8. Okay, right here. Okay, that is for this example. Okay, let's take a look at another example. Let's say we have a crossover probability equal to 1 and mutation probability equal to 0, and we have the function here x3 minus x cubed minus 60 times x squared plus 900 times x plus 100. Okay, and then the x value must be between 0 and 31. Cannot be less than 0, cannot be more than 31. So x can be represented using 5 binary digits. Tadi 4 binary digits kan? This one is 5 binary digit. So, first you generate the random individuals. You generate random individuals. So let's say you generate 4 chromosomes. So you have 4 chromosomes, 4 different chromosomes, each have 5 binary strings. And then the x value can be selected between 0 to 31. And then you put the x value into the formula given. Okay, this formula. Okay, put the x value, then you will get the fitness value here. Okay, you get the fitness value and you calculate the total. Okay, the process is same to the previous example. Okay, you calculate the total. Okay, if you want to give the average, okay, you can also give the average. That means 7718 divide by 4 and you get this is the average value. Okay, now choose parents using roulette wheel selections and do the crossover point. Okay, do the crossover points. So for this example, they choose parents number 3, okay, and then parents number 2 to do the crossover. Okay, so let's do the crossover for these two. So you have parents number 3, binary string is 10111, and parents number 2 is 011111. Do the 1 point crossover and you will get a new offspring here. Okay, 11111 and 001111. Okay, and then choose another parents. Okay, P4 and P2. Okay, and then you do the 1 point crossover at any point. Okay, and then you will get the child here. All right, so you will have a new chromosome, right? A new chromosome, and then you calculate again and you will have a new total, and a new average. What we want to do is we want to find the the most optimum x value for that specific fitness function, right? So we can see from the original generation compared to this new generation, the average have increased. Okay, and then B2 was the strongest individuals in the initial populations. So it was chosen both times, but we have lost it from the current populations. Okay, so we have the value of x equal to 7 in the population, which is the closest value to 10 that we have found. Okay, so let's say you did for each values, okay, because earlier the condition was x is between 0 and 31. Okay, when you put the value of x 0 in this function, you get 100. You put 1, you get 941. You put 2, you get 160x. And then you have all this value and plot this graph, and then the one that at the top of the graph here is the optimum value that you want to see. Okay, so the most optimum value here is x equal to 10. Okay, right here. Oops. Okay, all right. So that's it for this module. Any questions? Any questions?
Tiada doktor.
Okay. Senang je kan if compare to you guys taking kelas calculus, kelas statistics dengan pusat sains matematik, this should be nothing lah for you guys. Alright. So just try to understand the calculations. Okay. You guys section 2. So section 2. Oh, I'll see you guys tomorrow for the lab session. Okay, lab session tomorrow. Download the lab exercise, the code on Kalam. Kita akan buat exercise on A star search. A star search yang kita belajar in a class last week. Okay. So if there are no question, I will see you guys tomorrow lah during lab session. And don't forget to fill in attendance. Don't forget to
Madam,
fill it. Yes.
yang nak tanya yang crossover tu, is it
Ha.
macam mana we choose it lah?
You can choose randomly. Concept